So today, Common Core, we are really talking about, again, factoring polynomials. But more specifically, I want to talk about cubes, about factoring perfect cubes. Factoring perfect cubes. Okay? 11, 29, 17. Okay? So, example 9. It kind of looks like a perfect cube, but I need to make it a cube plus a cube. Now, 8 doesn't look like a cube, but 8 can be made into a cube. 2 cubed. You guys agree on the little side work? I know that 2 cubed is 8. You all right with that? Does that make sense? 2 cubed is 8? Because what I need to do is make it a cube plus a cube. So I rewrite this as an x cubed plus a 2 cubed, right? It has to be a cube plus a cube, okay? So I've got an x cubed plus a 2 cubed, all right? So I'm going to recognize that it is a cube plus a cube. So I need to use this factor formula. Well, to make it easy on the side then, I'm going to make sure I say that, well, in this case, my a is x and my b is 2, all right? So my little here, I'm going to let my a be x, because so then my a is x and my b is 2. See, I'm working that out so I can put, that's my x cubed, that'd be my a cubed plus my 2 cubed or my b cubed, because I want to use my formula, okay? So I've got my a and my b, and I'll just put the x's and the numbers into the formula, okay? So let's see how it works. I'm going to go parentheses, because I'm using this formula right here. I'm going to go a plus b. That would be just the x plus 2. Right? Because a and b are x and 2. Right? Parentheses. My formula says go a squared. Well, that would be x squared minus, because that's my formula says minus ab. That's that times that, which makes it 2x. Plus b squared. Well, b is 2, so 2 squared is a 4, and that is it. Done. Now some kids say, well, can't you factor that again? You can't, because if you could, it would be a different formula, right? So you're finished. Pretty easy, isn't it? I mean, it's really easy. Now the hardest part about this is just remembering the darn signs, but that's why it's going to stay up there on the board, so you don't have to worry about it, okay? We'll just look at it. It's right there, okay? Example 10. Okay, example 10 is also, it really is a cubed. It really is, but we have to rewrite this. So another way to write this was a 2x cubed minus a 3 cubed, right? Because 27 is the same thing as 3 cubed. Do you agree with that? 3 times 3 times 3. So it really does fit the rule. This time, though, I'm going to let I've got a's and b's in my formula, right? So instead of a's and b's, in this case, I'm going to let my a be my 2x, and my b is my 3, okay? Don't worry about the negative 3, because you have a formula that deals with the negatives, right? So some kids are going, well, Mr. Davies, isn't b negative 3? No, it's just 3. In the formula, it takes care of it. A subtract b, okay? Think of it as a subtraction. Don't think of it as a negative, okay? Think of it as a subtraction, okay? Cube subtract cube is this form, okay? There's my a, there's my b, okay? B is 3, not negative 3, okay? So let's check it out. Let's use our formula, okay? So a is 2x, b is 3. Let's plug the numbers in the formula. So it's going to be parentheses. I'm going to go a, which is my 2x, minus b, which is my 3. So I'm just plugging the values for a and b into my formula. Parentheses. A squared. So I got to square that, which is a 4x squared. Okay, I got to square that because I need an a squared. So I'm going to square that, which makes a 4x squared. Plus ab, so I multiply these two. Okay, ab would give me a plus 6x. Then plus b squared, that's going to be plus 9. That's my answer. It's really pretty easy. Thumbs up? Sideways? Okay, go ahead. Go ahead and ask.
2 plus, oh, no, 2 plus 3?
No, two times. AB is
Oh, I see.
Right. Okay, good. Okay, thumbs up. It's actually pretty easy. The only trick you have to do is make them first. Okay, again, the only trick you have to do is first make it into a cube. The first thing you have to do is make it into a cube. First thing you have to do is make it into a cube. 27 is not a cube unless you write it as 3 cubed. 8 is not a cube unless you write it as 2 cubed. So you have got to make it into a cube, okay? Other than that, it's not too bad. Okay, let's shift down to example 11. Now, example 11, it doesn't look like anything. It doesn't look like anything, but, and I've said it before, always common factor first, if you can. So let's put that down there. Always common factor first, if you can, okay? So if you can common factor, we should. So in example 11, we can. They both have a common multiple of 5, and they both have an x in common, okay? So if I common factor a 5x out of both terms, I'd have an x cubed plus 8. All right, now that is identical to what we just did, isn't it? That is identical to what we just did, isn't it? So we've already done x cubed minus 8. So let's just copy that down. 5x, and we know the answer is the x plus 2, x squared minus 2x plus 4. Right? And we could have gone through the formula, but we already had the answer. Maybe we could have done the formula again, but somebody smart's going to say, Mr. Davies, we already got the answer up there. Why you do that? And I'd have to admit, you're right. Why do it again, right? Okay. Thumbs up. Okay. All right. Turn the page. I'll wait for you. Now tomorrow, I've already recorded it. Mr. Moody's here. If my pacing's too fast, will you tell him to pause it, please? Please be brave. Speak out. If I'm going too fast when I'm recording tomorrow, say, slow down, Mr. Davies. Will you pause it? Okay. All right. Turn the page. All right. Example 12. Well, it could be a perfect cube, couldn't it? I think 125 is a 5 cubed. 5 times 5 times 5. So the first thing we have to do is we have to make some cubes. 5 cubed is 125, and I know that x to the 6 is the same thing as x squared cubed. Well, that's kind of tricky, but it's going to work, isn't it? So I have to have a perfect cubed, right? So it is going to be, in a sense, a 5 cubed minus an x squared cubed, right? And the formula I'm going to use, if I go back over the board, I'm going to use this one right here, right? I'm going to use this one right here, okay, because it's the cube, subtract cube. So, and I'll even write that down. So the one I'm going to use is my, it's going to be my a minus b times my a squared plus my ab plus my b squared, right? That's the formula I'm going to use because that's my factoring my perfect cubes if it's subtract, okay? All right, so in this case, let's let a be 5, right? And let's let b be my x squared, okay? And then I'm just going to plug the a and the b into my factoring formula, okay? So there's my a is my 5 and my b is my x squared, and let's just plug those values into the formula. So, okay, parentheses, 5 minus x squared, parentheses, let's see, a squared would be a 25, plus ab. So if I multiply those two, I get a positive 5x squared plus a b squared. So if I square that, I get an x to the 4th. Okay, there it is. Now we're in Algebra 2. I like it. We're done with Algebra 1. Good. Now we're going to start doing, yeah, I was getting bored with teaching a whole quarter, half our time going back over Algebra 1. That's just depressing, isn't it? I don't know. I don't know how we're going to change that. I don't, because I do not like teaching Algebra 1 again. And if you're a smart kid and you're motivated, then I shouldn't have to teach Algebra 1 again, right? Problem is we got too many kids that never learned Algebra 1 because you were lazy. Truth.
Because we had Mr. Barr.
No, because you were lazy. Okay, now, example 13. Example 13 is a totally different question. It's a totally different question. This is really the same thing as x minus 5 times x minus 5 times x minus 5. It really is. So this one's not factoring at all. This one's multiplying. Now there's two ways to do it. We could keep multiply, 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 or I'm going to use Pascal's triangle, right? So Pascal's triangle, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, because I want the third row of Pascal's triangle. I want that row. I want the third row because of the cubed, right? Okay. Now you could multiply it all out, but to me that's kind of a pain. I really think it's faster this way. So I'm going to put my 1, my 3, and my 1 down. Okay. All right. So let's go x cubed, x squared, x1, and no x. Okay. Right. Went 3, x cubed, x squared, x1, no x's, and then I'm going to go negative, I got to use the negative, negative 5 cubed, negative 5 squared, negative 5, whoops, to the 1, and no 5's, okay? So I've got negative 5 cubed, negative 5 squared, negative 5 to the 1, I don't really need the 1 power, but I'll put it there, and then no x's, right? No 5's, no 5's. Put plus signs in between, plus, 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 and let's just finish it up, okay? So I have an answer of x cubed. Negative 5 times 3 is a negative 15x squared. Okay, 5 squared is 25. 5 squared is 25. 25 times 3 is 75. Positive 75x. Negative 5 times negative 5 times negative 5 is negative 125. Okay, and I like to put that one in there just so you see the difference between factoring cubes and multiplying it all out. The difference is if it's parentheses cubed, you got to write it 3 times and multiply it out. In these, there's no parentheses, so it's factoring. Okay, so here's our homework. It's not a lot. It's not a lot. It's not a lot on purpose because I also gave you your cube to take care of, okay? All right, there you go. And hopefully we'll get the cubes in today at the end of the period, okay? And